Hi everyone. Today we're going to be talking about writing point slope form. This is lesson 2.2-5 for Algebra 1, looking at the point slope form of a line. So our goal today is to write an equation using the point slope form and then change it to one of the other forms if we need to. The point slope form is a very convenient, very easy way to write a linear equation. There's not a lot of calculation typically involved in it. So it's a nice place to start when you're writing a linear equation. And so our central question today is just how do we do that? How do I write a linear equation using point slope form? So this is what point slope form looks like. Y minus y1 is equal to mx minus x1. So we've talked about a lot of these terms already. The m represents the slope of the line. X and y are just the variables in the line. They're the input and the output for the equation. And then x1 and y1 are the things that we're going to be using today. x1 and y1 just simply represent some point on the line. It doesn't matter if it's the y-intercept or the x-intercept or any random point on the line. All we need is some point and the slope, and then we can generate the point slope form. So here's a first example here. They give us, right, we're given the slope is 4/3, and they're given a point here. The point here is 7, 1. And so remember our point slope form is y minus y1 is equal to the slope times the quantity x minus x1. Okay, and so they give us the slope, so I know that. And we have a point, 7 and 1. So this is going to be my x value, and this is going to be my y value. Okay, these are the values we'll use in our equation. So to write that point slope, I just have to fill this in. So this is y minus 1 is equal to the slope, 4/3, x minus x1. In this case, x1 is 7. Okay, so there we have it. We have a linear equation. We use the point slope form, and we didn't really have to do any calculations or anything like that. So it's a nice way to quickly get an equation. Now, a lot of times they will ask you not for a point slope form, but they'll ask you for a slope intercept form, or they might ask you for standard form, in which case we can, we know how to do this. We've done this type of problem before, but we could also use point slope form as a starting point. And so I can say, well, I'm just going to take this equation, right, and I'm just going to rearrange it and make it look like slope-intercept form. So that's what I'm going to do down here. So I've got y minus 1 is equal to 4/3 x. Now, my first step here is I'm going to go ahead and distribute this. So I'm going to do 4/3 times x and then 4/3 times negative 7. So I'm going to do 4/3 times x and then 4/3 times 7 to multiply this, right? This is a fraction. We would write this as 4 times 7 and then 3 times 1. So this would be minus 28 over 3. Okay, so we just multiply the top there. Okay. So we're close to having it in slope-intercept form. Remember, slope-intercept form is y equals mx plus b. And we're close to that. We've just got this negative 1. We've got this minus 1 on the left-hand side. So I want to get rid of that. So I'm just going to add 1 to both sides. The screen's kind of flipping out there, but that's all right. Okay, so now, and I add those together, I've got y all by itself, which is what we want. I've got 4/3 x, so there's my mx. And now I just need to figure out the b. So I need to add negative 28 over 3 and 1. So these are fractions, but don't freak out. We know how to do these, right? We just have to get a common denominator. And so if I think about 1 I can actually write as 3/3, right? So 3/3 is equal to 1. And I don't know why my 3's are coming out so poorly there, but okay, so I've got negative 28 plus 3. And I don't need to add these together, right? I'm just adding the numerators together. So I've got negative 25 over 3. Boy, that's really not working. Okay, so there's my slope-intercept form. So I've got y is equal to 4/3 x minus 25/3. Whew, that's ugly. Okay, so there we have. We started with the slope and a point, and we were able to put it easily into point slope form. And then with a little more work, we were able to rearrange that and put it into slope intercept form. Okay. Now we could have put it in slope intercept form the other way, which is to plug in y equals mx plus b, plug in the m and the x and the y, and calculate b. We would have come up with the same answer. And so you can give that a try and see if that works. And there's really, whichever way works better for you is what's best. Whatever makes sense in your head. If you like to put it in slope intercept form, if you like the y equals mx plus b and substituting and solving for b, that's great. Do it that way. If you like the point slope form, right, you can use that as a starting point and then just kind of quickly rearrange things to get it into slope intercept form. Okay, let's look at another example. So here we're given 2 points. So we don't have the slope, but we do have 2 points. And so we can quickly figure out the slope from there. So I can tell my slope here, if I look at my y values go from 3 to 2. So it's going down by 1. And my x values are going from -8 to 5. So -8, right, all the way up to 5. -8 all the way over to 5. That's a change of 13. So it's going up by 13. So I have my slope, right? And now I also have a point. In fact, I've got 2 points, right? This is x1 and y1. This is x2 and y2, or vice versa. It doesn't really matter which one you say is the first point and which is the second point. I'm just going to pick one, okay? And I'm actually going to pick the 5-2 just because I like working with positive numbers. So I'm going to write my point slope form. So this is going to be y minus 2 is equal to -1/3 x, quantity x, minus x value. So x1 would be 5. And so there's my point slope form. Okay, do a quick calculation of the slope there, and then I've already got my equation. So again, not a lot of computation that has to go on there. Now, if I'm asked again to put it over, whoops, I forgot my one here, it's 13. If I'm asked to put it in slope-intercept form, well, again, I can do that same process. I can translate this, I can move this around and distribute and get this to be in slope-intercept form. So to do that, I would have y minus 2. And if I distribute, I get -1/13 x and then I've got -1/13 times 5. That gives me positive 5/13. Remember, I just multiply the numerators together. Okay, and so I'm close. Again, all I've got to do is get rid of this 2. I'm looking for y equals mx plus b, so I've got to get rid of this 2 here. So I'm going to add 2 to both sides. And so I get y is equal to -1/13 x. And then to add this, right, again, I need common denominators. So if I turn this into 13ths, right, if I took this and made it 2 over 1 and multiplied the top and bottom by 13, the 3s are really turning out bad today. So I get 2 times 13 would be 26. So 2 over 1 is the same as 26 over 13. And so when I add 26 to 5, I get 31. So plus 31 over 13. Okay, so there is my slope-intercept form. electronic cheat there. So there's my slope-intercept form. So I know it crosses the y-axis there at 31 over 13, which is, we know that is what, 26, it's 2 and 5/13, right? And then it has a slope of negative 1/13. Now, would I use this form to actually graph it? Probably not. If I've got 2 points and I just need to graph it, I'll just graph those 2 points and draw a line through it. But if I need that slope-intercept form, here's a way to get to that without a whole lot of calculation. That point-slope form gives us a good starting point, and then we can rearrange and try to get it into those other forms. And then our last example here, notice here, right, they're telling us to put it in standard form. So remember that standard form is ax plus by equals c. So that's standard form. And remember that the limitations on this, or the notation that we use for this, a, b, and c all have to be integers. So no fractions, no decimals, no square roots, no anything like that, right? If we have any of those, we have to get rid of those somehow. So, and then, so a, b, and c have to be integers. The x and the y terms have to be on the left-hand side. The constant term has to be on the right-hand side. And then the other thing is that the a value here, right, this leading coefficient, this a value has to be a positive number. So if it comes out to be a negative number, we have to change that somehow and reinterpret that. All right, so that's what we're trying to get to. Notice it doesn't say anything about point slope form this here. It's just asking for standard form. And that's a fairly common thing, right, that you'll be asked to do. But we can use point slope form to help us get to this point. All right. We could also use slope-intercept form, and it really, it doesn't really matter. The choice of which form to use to start with, totally up to you. What matters is that we get to that ending point, and that our math steps are sound there. So they give us an x-intercept, they give us a y-intercept. These are actually 2 points. So I'm going to list this. Remember that the x-intercept is where it crosses the x-axis. That's at the point 4, 0. Okay, so the x-intercept at 4 is the coordinate 4, 0, and when the y-intercept is 5, that's where it crosses the y-axis. That is the point 0, 5. Okay, so we actually have 2 points here, even though they give it to them in a little, give them to us in a little different format. So for any of these forms, right, I want to find out the slope. I want to know the slope, and so I have that. I have 2 points here. I can calculate the slope. So my slope is. So I'm going to look at the y values from 0 to 5. From 0 to 5, the y values go up by 5. So from 0 to 5, it's going up by positive 5. And then from 4 to 0, it's going down by 4. So my slope here is negative 5 over 4. Now, now we have to get to standard form. So a couple ways we could do that. We could start with point slope form. Right? We could start with point slope form. We could also start with slope intercept form. Okay, either way works. And then again, whatever method you choose doesn't matter. We have the y-intercept and we have the slope. Okay, so that's a nice thing to notice there. But I'm actually going to, just for the purpose of demonstration, I'm going to show you how to do this with point slope form. Okay, so with point slope form, I'm going to go ahead and write this out. I'm going to use this point right here, 4, 0. Okay, 4, 0. And so I'm going to write this out. I've got y, right, minus y1. My y1 here is 0. So I got y minus 0 is equal to my slope, which is negative 5/4. And then I've got x minus 4. Okay, so I can pretty quickly get to this. Now, if I simplify this, look, I get y is equal to negative 5/4 x, and then I've got negative 5/4 times 4 divided by 4. I've got negative times negative is going to be positive, and then 5 times 4 divided by 4 is just 5. Okay, so you see what equation I end up with here when I do this in point slope form. When I simplified that, I actually got slope intercept form. Okay, so you can see that I can kind of move back and forth between these things pretty easily. Now, they're not asking for slope-intercept form or point-slope form. They're asking for standard form. So what I want to do is I want to get this x term over to the other side. I've got a fraction here with my x term, so I want to get rid of that fraction. Right? And I want to make sure that when I'm done, that my leading coefficient, my a value, is a positive number. So first thing I'm going to do is I'm going to get rid of this fraction. So I'm just going to multiply everything by 4. Okay, so that fraction says -5 divided by 4. I'm going to undo that division. I'm going to multiply everything by 4. Sorry, by 4. So I'll just distribute this out. Right? So I've got 4 times y, so it'll be 4y. And then again, I've got 4 times -5 divided by 4. The times 4 and the divided by 4 cancel out. I get -5, so I get -5x. And then plus 20, so 5 times 4 is 20. Okay, I'm going to come up here now, just because I'm running out of room. Now I'm close, right? I've got rid of the fraction, so I only have integers, and I want to get this -5x over to the other side. So I'm just going to add 5x, and a -5x, I'm going to add 5x to both sides. And so up here, I get 5x plus 4y equals 20. Okay, so let's double check this. Standard form, ax plus by equals c. I've got the x and the y terms on the left-hand side. My x term comes first. I've got all integers here, right? There's no fractions anymore. We got rid of those fractions. And my 5 is a positive number, which is what I want. I want that a value to be positive. So there is my standard form. 5x plus 4y equals 20. So I've got 3 different versions of this equation right here, right? I've got the point-slope form, and then I've got slope-intercept form, and then I've got standard form. And so that's really our goal today, is to be able to not necessarily be able to memorize what the formulas are, or memorize what those forms look like, but to be able to pick a form that's most convenient for us, right? Pick a form that's going to work best for the problem that we're working on. And then if we need to be able to translate, right, to be able to reinterpret that equation in different formats. Okay? So if we need to move to standard form, if we need to move to slope-intercept form, if we need to move to point-slope form, we need to be able to move freely between those three versions of those equations. And then we also want to be able to generate a table of values, and we also want to be able to create a graph of that. So we've got 5 different representations of a single line. And again, which one we use, which one we choose, is dependent upon what our circumstance is, what problem we're trying to solve, and what's going to work best for us to do that. Okay, so I'm going to go ahead and stop the lesson here. Please let me know if you have any questions.